Okay, so let's look at our calculators and see how we can do them. Use them. Just turn them on, go to calculate, hit enter. Okay, I'm going to delete mine. Okay, it doesn't want to delete. There we go. Okay. So the first one we're going to enter on that page is the log. In order to do that, hit Control, Log. Okay, on my calculators, if you're using my calculators, it'll look like this. It'll have a base right there. Okay, don't put anything in there. We're assuming the base is 10 right now. Okay, so you're going to arrow over, and in those parentheses, hit 3 times 5. And hit enter. And you get this, which doesn't help me much. Okay, because I still don't know what that means. So you have to hit Control, Enter, and it will round it for you. So log base 10 of 3 times 5, or of 15, because 3 times 5 is 15, is 1.176. Round to 3 decimal places for me. So on your notes, you're going to put 1.176. Then we're going to go back to our calculator. And now hit Control, Log over 3, and outside the parentheses you're going to do times, Control, Log, get out of the base, of 5. So you're going to multiply the log of 3 times the log of 5, and then hit Control, Enter, to get 0.3334. So we're going to go back here. And put 0. Nope, not going to let me write. So write it right there. And when it lets me write it there, I will put in 0.333. Okay, then we're going to go to our calculators and put the log of 3 plus the log of 5. Oopsie, I'm in the base. Let's delete that out. Arrow outside the parentheses, and then plus Control Log out of parentheses of 5. And then Control Enter. And I get 1.176. You can't do the log base 3. You have to use a calculator for this. Won't get my calculators, but you have your calculators, which can do the same thing. Okay, I'm using my calculators because I can demonstrate it because I have that computer one. Make sense? So if you want to use your own calculator, you can totally do that too. And so it should be 1.176 right there, but it won't let me write right now. Any questions on how to do this? Okay, go for it. Okay, let's check how we're doing so far. Check your numbers, you guys. Make sure your numbers are accurate. Okay, and then write a rule, or write down what you're noticing. Okay, what's the rule for logarithms then? Or the properties? Or like exponent properties, so what are the properties of logs? Then if we look at the graphs, let's try that again. These are what our graph should look like if you graph all three of those. Yeah. .36? Oh, sorry, I had that wrong then. Okay, let's go back. Sorry, this one's wrong, they're telling me. This should be 0.36. There's an extra 0 there that shouldn't be there. Any questions over that? Okay. So did anyone come up with a rule for when I multiply numbers with logs? Yep. Okay. So when you're multiplying, what can you do also that will give you an equivalent answer? And add them, right? So if you multiply inside the of, another way to find that same value would be to take the log of each of those numbers and add them. Okay, the next group of them. Can someone just try that property? Yep. Yes. Okay. So it's different. So when you're dividing, so like 10 divided by 4, you could also split those up and then subtract them. So the log of x divided by y could also be the log of x minus the log of y. Any questions over that? Okay, the next one then. Does anyone have that one? Yep. Yes. Okay, so I can take that exponent that was there, and instead of doing the power of that number, I can multiply the whole thing, the log of it, that number, times the exponent. The log of x to the y is the same as y times the log of x. Any questions over that? Okay. Another way to show this same idea is through graphing them. I started out graphing just the log of 3x. Okay? And that was the blue line that you can't see right now. Okay. Then I graphed log of 3 times the log of x. Because some people think I can distribute the log. I can do the log of 3 times the log of x. And it doesn't work that way. So that was the red one. You notice the graphs are different. They're not the same. Then I graphed the log of 3 plus the log of x. So I used my log property. That if I'm multiplying the two numbers, I can add them. And that gave me the same graph as the first one. These two are the same. Okay. Now if you graph these three, which would you expect to have the same graph in y? Yep. F of x and h of x and y. Because they're the division property, right? The division, if I'm dividing numbers, then if I subtract them, I should get the same thing. So f of x should equal h of x. They're equivalent equations. The property of division. Any questions over that? Okay, so we just discovered our log properties. Okay. On the back, I gave them to you. So we have our product property, which is right here. And the product property follows when I have exponents. Because remember, exponential functions and logarithmic functions are inverses of each other. So their properties are similar as well. So our exponent property was b to the m times b to the n, or x to the 5th times x squared, would give me what? X to the 7th power. I add those exponents. Same thing here. If I have log base b of m times n, I can just add those two logs, similar to our product rule for exponents. Okay. ln is our natural log. Okay, this chapter you will learn another value that is similar to pi. So we have pi, which equals 3.14. Now you're going to have e. Okay, if you look at your calculator, find the e button. It's the e to the x button. Find that. Okay. Plug in e to the first, and that'll give you the value of e. And let's see who has that. Okay, did you get that value? What is the value? 2.18. And it continues on forever just like pi does, right? Pi goes on forever, and so this e will go on forever as well. Okay? ln is the log with a base e. And we'll learn more about e in this chapter. Okay? Because it helps with compounding interest and stuff. So ln is the natural log. And so we will use them. And the properties work the same with ln and log. And we'll use log and natural log more throughout the chapter. Okay? Don't know. Okay. So then our quotient property is if I'm dividing two things with a log and divide them, I can subtract the two values. And that's equivalent. They're same. And then my power property is log base b of m to the x power. I can just take that exponent and move it to the front and multiply by it. Similar to my power property, when I have a power over power, I multiply the exponents. Any questions over that? Okay, we've also talked and kind of discovered these other laws. Log of base. Exponent rule is base. When you have b as the first, you get b. And we talked about log base b of b is 1. So that was when we were having like the log of base 5 of 5. That would equal 1. Okay. Same with ln. ln is the natural log, and so it's the base e. So ln of e is going to equal 1. Okay. Also the log of 1. So if we have b to the 0 power equals 1 for the exponent rule, so log base b of 1 equals 0. Okay, and ln of 1 will also equal 0. Because anything to the 0 power equals 1. Any questions over that? Okay, so let's use our properties. So we're going to state the property or properties used to rewrite each expression. So this log base 2 of 8 minus the log base 2 of 4 equals the log base 2 of 2. The subtraction one, if we go back, when I have a subtraction, I can also divide. Okay, so that is my quotient property. Because I just divided the 8 divided by 4 and got the 2. Any questions over that? Okay, the next one. Rebecca, what property am I using here? Am I multiplying things here and then adding and subtracting them over here? The power. So I've just taken this multiplication and I made it the power. Okay, now this one we added. Rika, what property is that? Product. So 3 plus 4 is the same as the log of 12. Does that make sense? Any questions over this? Okay, so we're going to write each logarithmic expression as a single logarithm. So when we have the addition, that means I can just multiply the log of 6 times 2, which will just be the log of 12. Any questions over that? Then this one is the ln of x plus the ln of y. Again, the same thing, it's being multiplied. We can multiply that and do ln of x times y. Any questions? Okay, then f, we have to do two properties here. I have this, so it should become the exponent of d. And then I also have the addition. So that means I should multiply the e and the d cubed. So it should be the log of d cubed. I'm going to do this in 2 steps just to make sure we see what's happening. Plus log of e. Then because it's plus, I need to multiply those 2 values together. So it's going to be the log of d cubed times e. Any questions over that? Okay, do the next one on your own. Okay, we're back up here. So we're here. So this should be the log base 3 of 2 cubed plus the log base 3 of 4. Okay, that's going to be the log base 3 of 8 plus the log base 3 of 4, which gives me the log base 3 of 32. Any questions over that? We're all good? Okay, the next one then, we're going to do a bunch of stuff. So we're going to take the 3 and we're going to make it the exponent. So it's the ln of 2 cubed plus the ln of 4 minus the ln of 16. 2 cubed is 8. These we're going to multiply, and this we're going to divide. So it's going to be the ln of 8 times 4, which is 32, and then divided by the 16, which gives me the ln of 2. Any questions over that? We're all good? Okay, so you guys have another page, page 21. Skip 21. Yeah, because it repeats itself. So 22 has the same thing. So find page 22, and that's what you're on next. Okay, so we're going to expand now. So they wanted us to write it as a single log first, and now they want us to expand it. So this is going to be the log of x squared plus the log of y cubed. Then we have to take the 3 and move it to the front, and the 2 and move it to the front. So it's going to be 2 times the log of x plus 3 times the log of y. Any questions over that? Okay, do J on your own. So Peter, what did you get for that? You haven't done it yet? Okay, go for it. Very good. It's just being multiplied so you can add them. ln of 7 plus the ln of b. How about the next one? Sophia B. Haven't done it? Yep.
Log base 3a minus log base 3b.
Okay, the division just means you subtract them. Any questions over that? Okay, this one's a little tricky, so put a star by it. The radical is what's going to throw us off. Okay, does anyone remember how to write the radical as an exponent? Raise hands. What is it? 1 over 2. Remember we drew the tree and had the pretty leaves and then the roots to remind us that the roots are always on the bottom. So since this is a square root, the square root equals the exponent of 1/2. So this is like the ln of 3 times a to the 1/2 power. Okay, you have to write the radical as an exponent. As you move on in math, especially in calculus, you will have to do this. What we're doing right now is like a lot of what happens in calculus. You're having to manipulate the numbers to make it work for you and what you need. So these properties are how we can manipulate logs to make it work for us. And as we go on to solving logs, next section, we'll have to use the log properties to help us out. So this is going to become the ln of 3 plus the ln of a to the 1/2. Then we're going to take that 1/2 and move it to the front to multiply it. And we're going to get the ln of 3 plus 1/2 ln of a. Any questions over that? We're all good? Okay, this next one's a little tricky because the whole thing is to the 1/2 power. So I'm going to rewrite it like this. The log of 3d divided by e, everything to the 1/2 power. Okay. So since I want this 1/2 to be for everything, I'm going to take that 1/2, I'm going to put this whole thing in parentheses. And then do the log of 3. 3 and d are being multiplied, so I'm going to add the log of d. Then I'm going to subtract. I'm going to need that 1/2 again, the e. The log of e. Any questions over that? We're all good? Okay. Now to evaluate each expression using the log properties. Now we've already kind of did some of these in our last section. Class, what was the log base 5 of 5? 1. I don't know the log base 10 of 4 or the log base 10 of 25. So I can use my log properties, though, to add, which means I would multiply them and get the log of 100. Now remember that when the base isn't there, it's a base 10. So to evaluate this, we do 10 to the what power will give me 100. 2. So my answer would be 2. Because 10 squared gives me 100. This one we can use, we know what the log base 2 of 2 is. What's log base 2 of 2? 1. We always want to look for that because it makes our life so much easier. Because this is just 3 times 1 now. And again, what's the log base 2 of 2? 1. So 3 times 1 is 3, minus 1 is 2. You could have written it as a single log and you'll get the same answer, but this is much easier. Okay, so again, we have the log base 2 of 2, so this is just 1. So I get 4 times 1 here. What is 2 to the what power will give me 8? 3. So that gives me 4 minus 3, which is 1. Any questions over that? Okay. This one we might want to combine. Log base 4 of 1/4. I know that one. Does anyone know what 4 to the what power is going to give me 1/4? Negative 1. Since it's going to be a fraction, I know that my exponent has to be a negative exponent. And that gives me then this. I don't know 4 to the what power gives me 2. Some people might know. Does anyone know 4 to the what power is going to give me 2? 4 to the what power gives me 2? 1 over 2, the 1/2. Okay, but if you didn't know that, let's do this, and this will make my life easier probably. Okay, what's 2 to the 4th? Okay, plus the log base 4 of 2 to the 4th is 16. Okay. Now, what is the log base 4 of 16? 2. Because 4 squared gives me 16. So this is 1. Any questions over that? Last ones I want to check to see if these are true or false statements. So everyone try and see if these are true or false. Don't use your calculators. Okay, class. Is that true or false? True. Okay, because log base 3 of 9 is 2. And log base 3 of 27 is 3. And 2 plus 3 is 5. So this is true. How about this one? This would be the log base 4 of 7 over 3. Is that the same as the log base 4 of 4? No. So this is false. Okay, this one's tricky because this is log base 2 of 5. And this is log base 10, right? That's a base 10 written in there because it's not written, of 3. Will that work? No, this is false. They don't have the same bases, so I can't do anything other than simplify them if I could, but I can't simplify those. Any questions over that? Okay, your homework is the next page.